Hey, good everybody. Hope you're having a good Thursday. We're back for another episode of Meteorology Lab, and we've got some big changes on the way. And I took a look, and that star up there at the very top, just left of center, that is Arcturus, and it's a, I think, G-star. It's pretty close to what the sun is. And I didn't see anything else up in the sky at the time except for Saturn, which is a little higher to the south, and Antares was also up a little bit lower than that. Okay, so there's the charts, and I am getting a lot of work done on the book, and it's underway, so this is what it gets written in. This is a program called InDesign 4. Let me see if I can bring that up. It's actually about a 10-year-old program, and I'm still using it, but it works fine, so anyway. So that's continuing to be underway, and what you saw was just a very early draft, and it's going to be a lot different from what those pages show. Okay, well, we are under tropical flow here. However, it does have an easterly component. This is not a deep tropical flow out of the south like we normally see in August and September. Up to the north, we have a frontal boundary, which is quasi-stationary. It's been there a while. And that runs from about the Quad Cities through Kansas City, down to about Kingman, maybe Medicine Lodge, Kansas, down to Amarillo, and then up to about Colorado Springs. And then we've got kind of a backdoor front in Denver and Cheyenne. A little bit of easterly flow there. And the Rockies under tropical flow, so you go into the mountains, and it's actually 70 instead of 58 right here on the plains. So that's a little bit different from the winter storms that you like, The Shining. I don't know how many of you have seen that movie, but you know, you've got that guy landing there at Denver, and they've got a snowstorm going on, and he goes in the mountains, and there's snow there too. So probably what we got going on when that happens is kind of a deep easterly flow there with a storm system in maybe southern Colorado, and then it's bringing a lot of that polar air over the top, and then we've got moist air overrunning the top, and that's how we would get a pattern like that of a major winter storm going into the north part of the state there. So nothing like that right now, just a very shallow cold front there. Tropical flow all the way to New Mexico, and then we pick up the southwesterly flow in Arizona. So kind of in between there, a little bit of a trough in the middle of all this right there. Okay, let me go over to the charts here. Let's see, where are we at? Yeah, there we go. I'm trying to figure out where I want to go with this. I think what I'll do is I'll bring up the thickness chart. That'll be kind of a good start for the program here, and this is what we have right about now. This is isobars and thickness. So we're looking at the leading edge of that cold front way out to the west over maybe the Four Corners area, and then it kind of extends into northern Colorado, and then we pick up the front on the plains. This is more from Canadian origin, and that goes all the way to the Quad Cities, like we mentioned, maybe down to Amarillo. Not picking up very well on this chart because it's very, very shallow through this area here, but we know it's down in that region, so we're going to put that other front kind of like that right there. All right, then over the top, we got a little bit of warm air advection overrunning that at about 850 millibars. A little bit of cyclogenesis there in Colorado, and then out west, we've definitely got a cold air mass over the northern deserts out in this region here. So we're going to expect to find a little bit of a signature between Arizona and the northern deserts there. So we'll look for that there. In fact, we can just go straight to the charts now. Maybe do a top-down approach. Okay, so there's the 200 millibar chart, definitely showing that polar front jet over Nevada and Arizona. So we go between those two areas. Because of that cold air out over the northern deserts, we've got the polar front jet right in the middle, and it looks like we even pick up a bit of a subtropical jet flowing all the way down to the Gulf Coast and then down into the Gulf of Mexico. I wonder if this is going to shear out that storm coming from Nicaragua and Costa Rica. We've got a storm coming up from the south, and you can see the flow out over the Gulf very sheared at this time. So I guess if it's going to make it up here, that would have to die down a little bit, or otherwise it will take out the storm. Okay, let's go to 500 millibars, and we see strong flow in between Nevada and Arizona. And the big thing that we notice is there's also a temperature gradient between these two areas. So we go from 8 and 9 over Arizona to 18 and 20 below up in the northern deserts. So even up here at 500 millibars, this is 18,000 feet up, we've got a frontal boundary between those two areas. So -9 to -6, -9 to -8. Yeah, that's going to put it from about Bakersfield through around Area 51 up to, I guess that would be Ogden, and then up to Cheyenne, kind of like that right there. So that would be a 500 millibar warm front in between. Actually, the standard way to draw that is going to be kind of like that right there. So you would just have hollow tips there. Okay, if we have a front there at 500 millibars, we definitely know that there's going to be a front underneath near the surface. At least we should have a set up something like that right there. So 700 millibars, we do find front still in that area. We go from 12 and 11 in Arizona to 0 and -3 at Boise. Okay. Then we'll try going down to 850. And we do see a little bit of cyclonic flow over California there. So it looks like a little baroclinic low right around Coaldale and Tonopah, Bishop, California, kind of in that area just west of the Sierra Nevada. So we're going to expect to find, at 850 at least, a baroclinic low right there. And then maybe a little bit of a warm front, kind of like that. So this is at 850, 5,000 MSL. It's going to intersect the ground in this area right here. But now we've got a better idea where we're going to find the fronts when we go down to the surface, because there the analysis gets pretty noisy and it gets kind of hard to find a lot of these patterns. So we'll check that out. There's a southwesterly flow right there. Now Las Vegas showing a little bit of north wind, but at Desert Rock, southwest. So yeah, we're going to probably put the surface front maybe through Utah like that. And then I would probably just bring that up to Bakersfield, Mojave, and then off the coast right there. So that's going to be the analysis for tonight. So this is actually going to be a better analysis than we would see from the Weather Prediction Center or from Canada. This is pretty much exactly where the location is. So we can take that and we can kind of track the front over the next 24 hours and get an idea of what's going on out in that region and verify the models and make sure they're on track with that. Okay, elsewhere, let's check out up in Canada. That's where some of our air masses are going to come from soon. We've got a pretty deep fetch of southerly flow in Alberta, 70s in Edmonton. Pretty warm in the valleys of British Columbia there. Okay. Then out east, it looks like we're under the influence of a big low-pressure system out over the Hudson Bay area. So that's going to disrupt any progression of polar air southward, even though it is quite cold up in the northern Hudson Bay area. Okay, so let's, I guess, maybe take a look at that system out in the Gulf. tropical air pretty much covering most of the eastern U.S. right there, and then a little bit of Canadian polar air up in the northern plains there. So not much going on out in the Midwest. Okay, we do have, let me see if I can find that tab there. There we go. We've got Tropical Storm Nate forming in right along the boundary between Nicaragua and, what is that, Guatemala? I'm trying to remember the names of those countries. I think that's Guatemala there. No, that's Guatemala. This is El Salvador here, and this is, maybe one of you can take a guess there. I think this is Nicaragua, because that's that lake there near Managua. So I've forgotten what this country is. But anyway, there's Nate over that boundary line, 40 knots and 1,000 millibars. And we're going to expect that to head north across the Yucatan. That'll disrupt the circulation there. Looks like it's going to go up to hurricane status in the Central Gulf and then make landfall, according to NHC, around New Orleans, pretty much right onto the city right there. And then that'll track right up the Appalachians on Sunday night and Monday. And there's the ocean heat content, and I think this is a little bit better than sea surface temperature analysis, because there is going to be a little bit of overturning as the system moves over these waters here. Sea surface temperature is definitely helpful, but this will give us an idea where we might see intensification. Well, the Yucatan's going to disrupt that circulation a little bit, but looks like we've got a little bit of cooler waters during the approach to Louisiana there, so that could be a factor there. But yeah, there are some higher heat content values a little further east, so the track, I think, will be pretty critical there. Let me see if I can bring up a sea surface temperature map. Oh, we got a big directory here. That's interesting. Products all the way back to 98, so you can look up Katrina and stuff like that. Oh, that's... Yeah, I got to shut that off because that's still loading, and that's going to probably disrupt the webcast. I don't know, it got pretty far. Okay, let me go through their directory here, sea surface temperature. Yeah, okay, yeah, we're good to go here. All right, that's going to be Pacific. Okay, I guess we're going to have to use this graphic here. Yeah, that works pretty well. Okay, that's current 5th of October there, and looks pretty homogeneous from east to west there. Maybe a little bit of a weakness right there. Temperature's more on the order of about 28 to 29, and then closer to maybe 29 in that area right there. Very slight difference, but if there's any strong overturning, that could be a lot more of a factor there. Okay, I think we can head right into the graphics here. This is kind of the mesoscale forecast. So tonight, we know that there's a frontal system through the area just north of Las Vegas, out to the mountains around Mojave. So this is modified polar air to the north of that, and then our deep tropical air that's over Arizona and southern California, like that right there. So yeah, front just north of Los Angeles there. It's very interesting how the ocean waters show things very homogeneous offshore, and you would expect there to be a little bit of a contrast there, but I guess it's modifying the air behind the front pretty strongly. And let's head to the plains. And this evening we find that Canadian front. Let's see, something looks off here. I remember that front being a little bit further south. Let me check that out. Yeah, see, I'm going verbally. I remember there was a frontal boundary from the Quad Cities down to Kansas, and I went down to Kingman, and now I'm seeing different data here. I wonder where I got those values. I must have been looking at some other graphic. Okay, well, yeah, there's definitely an easterly flow there in Cheyenne and Denver. So anyway, yeah, this looks more consistent with that other product. And that's the NAM right there. And I guess the front is a little bit further north than where I had mentioned, but there it is nevertheless. And then down in Texas, we see the very deep tropical air right there. And now that we've got an understanding where all the air masses are, we can, this is really when the SCUTs will be helpful, because now you have a better idea of what you're looking at. For example, let's see. Yeah, sometimes I get lost in all these tabs here, and I'm trying to find what. Yeah, there's the SCUT right there. Okay, let's take a look at the deep tropical air over Tucson. And we can look at this evening's data. We'll go to 6E. So we're going to be looking at evening data. And there's the Tucson sounding for this evening. And this is showing very dry conditions, very strong heating at the surface, and you see the almost dry adiabatic lapse right there. So this is pretty typical of what we see in the deserts during the warm season. Then a little bit of humidity right around 14,000 feet. You can get some cumulus going there, especially over the mountaintops. And then the air mass above that is quite warm. So at 500 millibars, we're seeing temperatures there close to -5. So if we go a little bit further north, we can go to Flagstaff. This is over higher terrain, but you can see a very similar SCUT there. Then we'll go to Vegas. A little bit of a difference there. Very warm temperature profile, but we're missing the moisture. It's just dry all the way up. Then we go to the northern deserts. The next one up, I guess, is going to be Reno. And what we see here is temperatures very, very steep lapse right there. And it looks like the surface values are close to about 16, 17, which is going to be about 63 Fahrenheit, 62. So that's kind of cool. And then going up higher, there's a lot of cool air. At 500 millibars, we have -17 Celsius. So what's happening is the cooler air is advecting in from the northwest. You can see that right there. And when you put cold over warm, especially very warm desert air, you get very strong lapse rate and very strong overturning. This is a very steep static instability there, and that's going to mix during the days we get solar heating there. And so that'll carry some of the warmer air to the upper levels, and then some of the cooler air down. And this mixing there kind of mixes out that difference there, and so we kind of see kind of a very gradual cooling, and the SCUT line just kind of shifts over to the left there as we go north. And then in the core of the polar air, that's that's going to be around the Boise City area there. All we see is just a very unstable SQT, but shifted over very far to the left. The desert SQTs look more like this, with a higher troposphere. And here you can see the troposphere is way down to 28,000 feet there. So if you're taking a flight to Chicago to Seattle, for example, or Houston to Seattle, you're going to be way up here. You're going to be in that stratosphere there, and the airplane is going to be taking in ozone. So you can directly detect that if you have like some sort of ozone detector or anything like that. That's actually how they look for the stratosphere folding down to lower levels. They look for ozone as kind of a tracer gas. Okay, I think we've gone through most of the charts here. It's kind of a fair weather situation, so not really much to talk about there. So let's head to the forecast. I guess we'll stop and look at the IR real quick. Okay, so we know this area here, this is all tropical, basically a deep tropical feed from the south there. Then you see up there in the northern deserts there, that's air flowing down from the south. And then we go down to the lower latitudes, and you can see the system coming together there along that coastline. Let's see, Nicaragua, Guatemala, Honduras, that's right, okay. I'm sure one of you got that right, and then there's Belize right there, and this is Mexico. So that'll be coming north. And there you can see that very strong flow across the Gulf from the northeast. That's strong shear. So the system will be heading into that, and we'll have to see what happens with that. This is water vapor imagery, and you can see that the plume of the deeper moisture is over West Texas, all the way up to Kansas. So this is all going to be higher precipitable water all the way up. And let me see if I can bring up SQT in the middle of that. We'll go to Midland, for example. And Midland, yeah, does show very moist SQT all the way up. So these are going to be some very moist values. The line shifted over to the right. And basically, if you mix that all the way down to the surface, the average column there is 57 dew points all the way up to about 23,000 feet. So maybe if we had a little bit more moisture, we would get some widespread showers there. And then one more SQT, we'll look at Amarillo, and yeah, very deep moisture all the way up to 18,000 feet there. And one other way we can look at that is with precipitable water. Let me see, do I have precipitable water? I think I have one of those graphics here. Okay, got to go through some of my charts here. Okay, yeah, there it is right there. And there's the chart, the scale off to the left. So basically the first green is an inch, and then it goes in half-inch increments, and yeah, there's that plume of tropical air flowing up to the Midwest. And precipitable water is basically what would happen if you squeezed out all the moisture in the atmosphere and it all went into a rain gauge. So it's a measure basically of your mass per unit area at the ground. The measurement is kilograms per square meter. That can be converted off to inches, and that's what we have here. So if you're able to rain out all that precip, you would have almost 2 inches in Oklahoma, and about an inch to an inch and a half over Texas. So that can be a very important way of measuring moisture when you're forecasting in the southern U.S. Okay, big change is on the way, and let me show you this. This is pretty cool. You can see this is total accumulated snowfall. And let's, before I do that, let me see just how much snow we have in the mountains. Can't really see it because of all those clouds there, but let's see, do we have one mountaintop that's not obscured by clouds? Not really. A lot of very unstable air there over the northern and central Rockies. But yeah, the mountains of southern Utah, completely dry. Maybe I just need to go back a little bit earlier. Well, even in the cold desert of Nevada, even through here, there's not any snowfall in those higher elevations. Okay, so this is the big change here coming up. It's very dramatic. Okay, there we go. So there's our snowfall. This is accumulated snowfall, so the values on here never actually go away as I go through. And you can see what's happening there in British Columbia. This is around Saturday and Sunday. So you can see all down the Rockies. I'm going to stop it there at about Tuesday, and you can see a lot of precip all the way from Taos and Santa Fe all the way up to British Columbia. And also, more importantly, snowfall now on the ground in Alberta and Saskatchewan. So now we're going to see the production of polar air. This is kind of like the first big change going into winter. This is kind of like the semi-permanent snowfall cover now starting in Canada. So there's more of it, a snowstorm in Edmonton, Calgary, into northern Saskatchewan. And so now we've got kind of like our permanent snow cover developing there in the Rockies. Okay, let's see. Let's go to the 200 millibar chart and just look at the changes there, because this is where we kind of see the shear there over the Gulf there. See that 65 knot flow, 55 to 65. Let's see what happens with that. Looks like it weakens by about Friday. See that now we've got south winds at 25 there. So it looks like that subtropical jet that we had earlier, that has died off. So that's going to really be critical here. And now the hurricane comes up Saturday. It's located in this region right here. And it's pretty much under a subtropical ridge there. And then just generally what we see over the next week or so, very strong trough coming through Colorado on its way eastward. And then another trough here. Yeah, here, let me show you something. Something very interesting. You see the lower heights up to the north, for example, and it's kind of a, you see one trough come through here. Okay, then that goes away, and then we have another trough here. And then kind of another trough coming in. It's just like one trough after another. Here's another one. And it's kind of all part of the same long wave. And I ran across this interesting graphic here from earlier today. And this is all modeled, and this is from Arnott van Delden did some numerical models of kind of like a conceptual paraclinic system. And let's see here. Okay, so what you're looking at is basically temperature with the turquoise there, and then the blue lines here are height. So what you see right here when we start out our model, we see kind of a cold air mass up to the north with a front right down here. And then we have the warm air mass down to the south. So let's run that. I'm just going to let it run. This is kind of like a few days of animation. And that's the development of a baroclinic wave there. And let me bring up the other graphic because it was a little bit more interesting. Okay, I'm going to let this load here for a second. So you see here's one wave come through, and then another wave comes in behind that. That goes away, another wave comes in from the west, and that's very similar to what we're seeing now. So you see that there's kind of like a permanent long wave in this area here. The dark blue lines showing that upper level low there. And then we have the short waves coming in. There's one right there. There comes another one, and then another one at very rapid intervals. There's one right there. That's a long wave trough. It's basically another wave. That moves on off to the north, and then here comes the next one. So that's very similar to what we're seeing right now. And then the low-level flow, that's determined by the shape of the turquoise lines. For example, right here you can see the warm air goes all the way up to this triple point right there. So basically what it's showing is a pattern kind of like this. Then up to the north we have an occluded front kind of like that. So this is a system moving off to the east. And you can see it occludes and then kind of redevelops further to the west. So this here is another system coming together right there. And then that moves to the northeast. So this is kind of like a way you can visualize these systems as they move through the flow up through like a couple weeks progression there. So I'll give you the link if you want to see more of that. And if you miss it, you can play back the replay later this evening. But it's at uu.nl, and it's called Simulation of Baroclinic Waves and Frontogenesis. And by the way, this is a vertical cross-section. I thought this is kind of what brought me there, because this shows the pattern from south to north through a frontal boundary. If you look strictly at values along a line that's horizontal like this, that gives you temperature. So you can kind of see very slow temperature change, very cold air mass, and then we have a gradient. There's a gradient right there, and then we hit the warmer air right around here. So what this is showing is that there's a frontal surface like that right there. And then the cold air is right there. And then the warm air is located right there. And above the frontal boundary, this black line, that's the zonal component parallel to the front. And that's the jet located right there. So the jet develops right above the gradient. You can kind of use that to kind of find where that front is. So at this time, this is over the central Nevada desert. And Arizona is located out in this area here. And northern Nevada and Idaho right there. So you can kind of use this as a guide to what's happening in the weather right now. Okay, over the next few days, let's take a look at this, and we'll start with the European model. And I've noticed the European model has not been quite as accurate this time around with the hurricane track, and the previous runs were bringing the track more into Florida, and now the European model has shifted that west, in line with the GFS. So we've got a 997 millibar low coming up towards Louisiana, and that's not very strong. This is kind of like a tropical storm to maybe a Cat 1. Makes landfall right around New Orleans and then moves up through Kentucky and Tennessee. And then that's out of the picture, and here comes our first big front coming into Texas on Tuesday. And then that moves off, and then we have another front coming in for next weekend. So here's the GFS run, basically bringing the system up into central Louisiana. And this is going to be on Saturday night. And lowest pressure looks to be about 995. So again, this is going to be tropical storm to Cat 1. Of course, we are going to have to kind of keep an eye on any rapid intensification, especially if it hits that pool of warm air off to the west. But it appears that the lower OHC and lower sea surface temperature is kind of a factor with the storm. Maybe a little bit of disruption, maybe just a little bit of shear possible. I'm wondering how accurately that shear is modeled there, because it really goes away very quickly, and I wonder if that's actually going to happen. All right, so remains going into Kentucky on Monday, and then here's the next system building in, moving into Texas on Tuesday night and Wednesday. And then just kind of quiet pattern through the rest of the week. You can see very strong northerly components. So we're going to have a lot of cool nights in the southern U.S. Next system regenerates up in Alberta and Saskatchewan, and a lot of instability there in the Rockies, and this is where we get a lot of the snowfall hitting the peaks there. Here comes the next system into Texas on Thursday the 19th. This is going to be a little stronger, much cooler air coming south. And then we hit the end of the run. And I think with the second system, it's going to feel a lot more like winter. And let's take a look at the temperatures. This is the GFS modeled temperatures. I'm going to look at the minimum. Okay, so we're going to look at the 12Z temperatures. Saturday morning, you can see temperatures there at 7 in the morning, 70s for the Mississippi River Valley, 50s for the northern plains, so pretty typical for fall. And then going into Wednesday and Thursday, temperatures much cooler. You can see some 50s and 60s in Oklahoma, a few 30s and 40s up north. And then later next week with the second system, look at these lows up in Saskatchewan, lows in the single digits there. So this is some very strong polar air production over that region and around the periphery, 20s. So that's going to really have an impact as that goes southward. And you can see a lot of 20s and 30s coming into the Central Plains. And let's see, we don't have a 12Z temperature here, but it's showing at 1 in the morning on the morning of the 20th, 40s and 50s there for North Texas, 40s coming in Chicago also, and then 30s up in the Northern Plains. So that's pretty, for 12 a.m., for 7 a.m., that's pretty solid 40s across much of the Midwest and Southern Plains there. So, yeah, that's going to be where fall really kicks into gear here. Okay, let's see. I think that's pretty much everything. I guess we can look at the streamline analysis. There's our system right there, north of Honduras, moving up through Belize on Friday night into Saturday. And then up into the Gulf, there it is right there, kind of a very, very westward track there. And then making landfall Saturday night around midnight around Lafayette. And I'll take a look at chat. Let's see here. Let me reload my chat page here. Wow, 23 viewers, and I wonder if that's because I came back to 8 o'clock. It's very interesting. Yeah, we did have a lot of viewers at 9 o'clock, but it was very erratic. Some nights we only had like maybe 10 people, other nights 25. So I wonder if this 8 o'clock schedule works better for everybody else. Well, anyway, hopefully I had my microphone on. Let me look through the chat. Let's see, Stephen Salyer. Haven't seen that name in a while. David Holcomb, Burl H., Ryan Toomeys, Michael Brow 13, looking for Tropical Storm Nate there. In fact, yeah, let me give you the satellite picture. Okay, there we go. All right, David Moore is going to be in West Texas tomorrow. Justin Pulliam, and Ryan are watching the storm there. The tropical storm there. Sue M joining us. Yeah, good to see you there, Sue M. Florida, flooding in South Florida. Very heavy rains past 24 hours. Yeah, I can definitely see that on the infrared imagery. Sue M's kitty is getting better. Oh, geez. Yeah, sorry to hear that, Sue. Mike Bexley also with us. Mike Estwick. Every time I mention Area 51, the webcast goes wacky. Yeah, maybe I should just do an Area 51 forecast and see what happens. You know, just kind of do a briefing just for that area. You know, I had, clearance when I was at Tonopah, so I would be a little bit worried about some repercussions, but I don't know anything special about Area 51, so it's probably no big deal. Tyson Miller, it's Honduras, yep. Ron Chalfant, Trish and Lou, can you show long range? Yeah, I just did. Looking at the wind shear in the Gulf. Tyson Miller. Thomas Copeland made it, but may not stay for all of it. Had to put his dog down. Oh, man. Yeah. Yeah, sorry, Thomas, here. Okay, so anyway, advanced meteorology lesson, yeah. Mike R., glad you enjoyed that. Waiting for a pattern change, and yeah, we'll look at it once again tomorrow. And it does look very much like a winter pattern for the northern plains coming up. Okay. So that's about all I got for tonight. I hope you all enjoyed the webcast. And I guess we'll see you tomorrow at 8 o'clock. Back to the book, and it's going to be an all-nighter for me. Take care, and we'll see you then.